My name is Rustin Webster. This is Jeremy Clark. We are going to give this presentation today. This is my third time here giving this presentation. I've given it at Swuggen Summit too in Nashville in a couple user group meetings. We weren't actually planning to give it this year, but they called last minute and asked if we would. So the presentation is actually an hour long. It's always been an hour long, and they put us in an hour and a half time slot, so there'll be a lot of time at the end for questions. We usually open it up. It's very informal. We want you guys to shoot questions at us at any time during the presentation. Feel free, you don't even have to raise your hand, we don't mind. Just look at it as more like a classroom focus group or something. So very open, very informal. Over the years, one of the few complaints is we're at SolidWorks World, but we don't actually use SolidWorks in this presentation. It's more of a data dump on you guys, more of an information. So we've tried to incorporate some SolidWorks into it this year. Jeremy's going to run most of that. A few little tips and tricks that we have when it comes to drawing stuff. But we're going to try to sprinkle in a little bit of SolidWorks for you guys this time. But go to the next slide. Oh, I got the little clicker. A little bit about myself real quick. I am from Wyoming, Illinois. I got my education, my undergrad and my master's at Murray State. Engineering, graphics, and design background. Currently, I'm about two and a half years into my PhD at UAB as I work for Army subcontractor at Intuitive Research and Technology. All our work, both of our work, come from Redstone Arsenal in the Huntsville area. Anyone Army-based government contractor in here? One? All right. Certifications, I am GD&T certified, the technologist level, we'll talk about that in a second, which is the lower level. SolidWorks, we have a lot of our SolidWorks certifications. We are experts, so if you have SolidWorks questions, we can try to answer them for you guys. And then I'm corrosion, but that has to do with my PhD too.
All right, so I'm Jeremy Clark. I got my BS and MS both at University of Memphis in mechanical engineering. Started off as working for a tier 1 supplier in the automotive industry. Then came to Intuitive about 7 years ago. Currently a senior mechanical engineer there. Again, I am a professional engineer. Most of the SolidWorks certifications, they've came out with a few new ones here in the last year or so, so I need to get caught up on those. And again, I am GD&T certified along with Rustin.
Yeah, the drawing one's new. We didn't even know about that one, so we're pretty excited about that new certification. So that'll kind of goes with what we're going to talk about today. Various projects, like we said, we both worked for the U.S. Army. I'm actually at school now, but previously we've worked on anything from Blackhawks to Apaches to C-27 cargo plane. A lot of IED protection stuff over the last 3 or 4 years. So we've done a lot of different projects, a lot of fun stuff. But a little bit about what we do and why we're very passionate about drawings and stuff is our company does a little different. We don't separate our projects. When a project comes down, they pick a project lead, one of us, and we do the design, the drawings, the simulations. We do the whole thing, all the meetings, the project kickoffs, CDRs, PDRs. So our engineers have to know how to do drawings very well with the standards. They also have to know how to do SolidWorks, simulation, design, all that stuff too. So that is a little bit different than some companies. The certification that we have is based on the 1994 Y14.5. And this is just kind of a little plug about it. It's a good thing to do. If you guys do a lot of drawings, if you say that your drawings are in accordance with either Y14.100 or 14.5, 94 or 2009, maybe think about taking the test. It's good. It's long. It's hard. It took a lot of studying. You pretty much need to know this entire standard and memorize it front to back. But it will show that you guys have some proficiency. You know it. You can recognize GD&T. Like I said, there's 2 levels. There's the senior and then the technologist. Once you get the technologist, you have to work for 5 years using GD&T before you can actually take the next level. And that really focuses on being able to apply GD&T. We looked up right before we came if the test is still tested on the 1994 or 2009. And it's still on the 1994. 2009, they said on the website, is September 2014. is when they plan to come out with a test on the new standard.
So a quick note about the standard. You notice the title of it is Dimensioning and Tolerancing, not Geometric Dimensioning and Tolerancing. So this covers all dimensioning and tolerancing. Most people, well, a lot of people still use coordinate dimensioning and tolerancing. It is covered in this standard. The first 2 chapters of the book are nothing but examples on standard ways to dimension and tolerance parts that don't deal with GD&T at all.
Which is a lot about what this speech is going to be about.
Yeah. And that's first. Anytime we get a co-op, intern, new hire, first thing I do is hand them this standard and tell them, read the first 2 chapters, understand it, have any questions, come to me, because when you start doing drawings, it has a wealth of information that you can rely on.
And we're not saying you have to use GD&T on every drawing or you have to use coordinate on every. We support both sides of the line, and we use both sides too. We just really feel like if you're going to say your drawing is in accordance with something, and I always say the drawing is law. If you send your drawing out to someone, it becomes legally binding. Just do it right. I mean, you should take a lot of pride in your work and make sure it's correct. So that's why we really look into this class. And anyone can take it, drafters, manufacturing, stuff like that. The little presentation abstract, what I really want to hit, this isn't a GD&T course. We're not going to try to teach you GD&T. If that's really what you wanted, I'm sorry, that's not really what this is about. There are some GD&T classes here. I think there's one actually this afternoon I saw on the little schedule. This is really going to focus on the fundamental rules. They're listed in the front of both the standards, the 1994 and the 2009. There's 16 of them now in the 2009. And they're fundamental rules that everyone should need to know. A lot of people forget them. A lot of engineers, like Jeremy came from a mechanical engineering degree, they don't really teach them. They don't teach drafting and design classes at that level. Where I came from, it was very, very much of an emphasis. So this is a good refresher for someone who might not have had it in college or had it a long time ago and has forgotten some of these fundamental rules. I think that's good. So to start with, we felt like this isn't one of the fundamental rules, but these are rules. They talk about notes in the standards. It's very simple. We don't really care how you format your notes or stuff like that. That's not really covered under there. But some of the things that should be included in your notes should include a header that said note, all in capital letters. I think most of us know that the only time you can use lowercase letters is if you're going to put a millimeter, mm, next to a dimension to specify that it's millimeters. Everything else should be in capital letters on your drawing. The notes clarifies the requirements of your drawing. So that's very, very important. It clarifies the requirements. So in other words, it makes it legally binding when you start to hand it to someone. It's located on sheet 1. If it's not, we've come across some big packages, Sikorsky and Boeing, where they put all their notes on a PDF document. But on the drawing, you got to tell them where those notes are. So, or if they're so long that they go past sheet 1 and onto sheet 2, you need to specify that there's a continuation onto sheet 2. Source of all this?
Y14.100 is
well, that's
part of it.
Yeah, 14.100 covers all the individual 14 standards. There's a lot of them. I can't remember what they all are. There's 4.1 or 0.41. There's a lot of them, and you really should probably have the whole set. I think I have Dropbox open. Jeremy on Internet Explorer has them all in there.
I think that's one of them.
We have access to a database called IHS. I don't know exactly what it stands for, but it gives us Information Handling Service. All right. We get it through the military. Any subcontractor, I think, can actually access it. But it has more than just ASME, too. It has ISO standards and everything in there. But that way we can go in and we can use these. And one thing that I will say about standards is the examples are priceless. There's all kinds of times that we get these weird parts and we design something and we just don't really know how to dimension it. We just go to the standard and we flip it through until we find a part that looks similar to what we want. And I will say in 2009 they added a lot more examples. They pretty much reformatted the whole thing and they added a lot of new examples and a lot more examples too.
So here's Y14.100,
yeah.
Section 2, references, and you can go through and find out
you can see them all.
The standard that they're telling you to use on how to dimension just about anything you want to see. So there's a list that goes, this entire side of the page and pretty much the entire side of the next page.
And a lot of them you won't use unless you have specific situations that you need, but they're very, very important to have access to those. Let's see. So general notes apply to the entire drawing or associated list. General notes and flag notes should be numbered consecutively, starting with 1. And note numbers of deleted notes shall not be renewed. We'll say one thing on there. We have levels of drawing packages: preliminary, reference, baseline. We reuse them until it gets to the baseline stage, and then we don't reuse them again. So that's kind of an in-house kind of practice.
All right, quick little thing on.
Oh yeah, the flag notes. Yeah.
On flag notes.
It's real simple.
A lot of people put you have to flag a note in your notes section to say that it's only applying at a specific location on the drawing, and everywhere that you want that note to apply, you put it in the drawing. So if we pull up a drawing and we want to make something flag, SolidWorks does allow you, if you double click on the note, so these are all numbered using your numbering format, you can click on it down here, border, and apply a border.
Yeah, when did that come in? Like 2011 or
2009 or 10,
oh, was it that long ago?
Works very well as long as you're in single digits. When you get up to multiple digit numbers, the formatting gets a little odd looking, but it allows you to keep the automatic numbering and keeps you from having issues there.
We separated ours into 2 sections. We have the general notes and the flag notes.
Okay.
And our flag notes started with I think the number lists on there.
And we've tried to do that where we sort of keep all the flag notes grouped at the bottom.
Yeah,
of the
we kind of keep ours
notes,
grouped at the bottom.
When you start,
What was that?
We kind of follow Bowen's lead on that because they have a computer generated one.
Mm-hmm.
And it doesn't have symbols in it.
Okay.
It's just a numbered list.
Okay.
They separated the general notes and flag notes.
Yeah. Well,
now, another note on flag notes is, according to Y14.100, you have to use them in your notes section. The standard does state that if you're using that flag note and referencing it in a bill of materials notes column or in a normal table that has a notes column, you do not have to put the flag there. You just need to put the number.
Yeah, that's kind of what you're saying, just all the way down.
So you can, but you don't have to.
Yeah.
So just a quick comment there.
Are there options for different shapes for your flag?
Yeah.
Our company does not use an equilateral triangle.
I don't think the standard states it has to be a rotated triangle like this. It says it has to be a flag. So in here, you notice there are circular, triangular. You can get
we see triangle the most.
Five-sided.
Triangle is just not equilateral.
Oh, yeah, no, like stretched out. Yeah, I think Bowen uses a stretched out. Or Sikorsky, one of those.
If it was up to me, I would probably use something like the 5-sided triangle.
Now, can you stretch the border? No, I don't think you can't stretch that border, so you're going to have to make your own. Yeah.
And it's a 2x3, and that's it.
Yeah.
That's the only option.
Yeah.
You have to custom make it.
Yeah, you'd have to do your custom. They don't have that.
Yeah. So, if it was up to me, I'd use one that was only 1 line thick, because when I don't know if you'll notice it here, but when I go, you see how it changes that formatting? It makes that entire line the thickness of the border. So that's where you run into issues when you start getting larger and larger flag notes.
Yeah.
But we're sort of made to use the triangular one based upon our customer's request. But a lot of different options there, and allows you to keep the standard numbering format so you don't have to number them manually. All right. And if I can find the right one.
And the last little bit is shall, will, and may. And shall is really the big one here. If you put shall, and if your notes section say anything with a shall, and the standard has a lot of rules that say shall to it, and we'll go over those here in a little bit, it's mandatory. So keep that in mind. It's a mandatory requirement. So, are you breaking the law? Some of the standards here, you're going to see that a lot. A lot of people use that as their very first note. That's what we do on ours. And then it covers all these individual ASME ones, like the 14.5. So that's a very, very common one. If you're going to use that one, you don't have to put the date after it. Some of the other ones, and you can kind of see how the dimensioning and standard has come about over the years. It started all the way back with Mill Standard 8 and 49, and it's just continuously progressed. The 1994 one was reaffirmed in 99 and 2004. Overall, I would hope that most people today are only using those three that are not crossed out, the 1994 or the 2009, on their drawing. If you're putting your tolerances on your model, like they were with, what's it called?
Dimension Expert.
Dim Expert, you're going to be looking at the 14.41. We don't use that. We've played around with it. Jeremy's tested it around. Some crazy parts are still really, really hard to put all the dimensioning and tolerancing on them. You know, if your part's pretty boxy and pretty simple, you can do that. But we don't use it, and we don't know many people that do use it yet.
They first came out with it in
Are you using it? You having good luck with it? Are you using it only in-house, or are you actually sending stuff out to manufacturers? Everything in-house? Okay. Yeah, but I'm saying you're not putting your dimensions on that part and then sending it to someone in China to manufacture it without a drawing, are you?
We have a local vendor outside our business.
And they know how to use SolidWorks and... Yeah, see, you got to make sure everyone else knows how to do it too. That's the thing, or you're stuck.
So a quick note on the Dimension Expert. They first came out with it, I think, 2009. I tried it. Didn't quite meet the needs. 2010, it got better. 2011, it got pretty decent, and I could do most simple parts. I have not really had a chance to play with it in 2012 or 13. So my hope is when I get a little time is I can pull it up in 2013 and that they will have the functionality even better than what it was before. Also, for anybody who deals with military customers, Mill DTL 31000 is currently under revision, is bringing a lot more of the digital product management, or
it's going to allow the procurement office to say you need to use this if they want to.
Well, not use, but it is allowing them to procure data packages in accordance with the 14.41 standard.
You're going to see more and more of it over the years. So more vendors that get it, more manufacturers that start to understand it. So you'll see more. Those are the two publications. We got the 1994 one. Some other good references. Here's some more of those Y14s that we use a lot. Alex Krulowski is the books that I've always learned on, and we use as reference material. Comes from the automotive industry, but he has a company that does all kinds of training. They're really good. Foster's are really good. The teacher who taught me way back when and is still very much a subject matter expert, he does all of Briggs & Stratton training for GD&T. They put GD&T, I think, on every drawing they do. And he's their leading trainer, go-to guy is Dr. Bert Siebold. He teaches at Murray State. He's also created a list of, I don't know how many rules they are, but fundamental drafting rules too. We have it. If you guys want it, I can email it to you. It's a really good little reference too. We usually hand it out.
And it's not, it's not a GD&T rule. It's just standard drawing practices that, I know I didn't get in college.
It's your drafting 101 stuff, that you just forget. So, but we have it. We can email it to you if you want to give us your email afterwards. He said we can distribute that for free. So one thing we want to point on here is if you look in the Y.100, down there it says dimension and tolerance should be in accordance with Y14.5M. So really, 1994 has an M after the 5. In 2009, when they upgraded, they got rid of the M. So if your first line on your drawing says in accordance with Y100, you're really using the 1994 because the 2009 doesn't have an M. So that's just kind of a mishap on their part. They haven't updated it yet. And then the other part that we need to hit on is you don't have to put the date with the 100, the .100. A lot of people argue back and forth.
Now the way that works is if you don't put the date on most standards, they're going to take the current revision as the standard that they're going to look at and compare it to. So basically you're saying anytime the standard's revised, look at the new standard. White 14.5 M, and it's stated in both Y14.100 and the 14.5, is if you reference that on your drawing, you must include the date with it. And that's because there's significant changes in the way that drawings are interpreted from one standard to one revision to the next on that. They bring in new symbols, they remove remove symbols. So 14.5 must include the date.
Okay, the fundamental rules that we're going to get into here, you can kind of see that I keep adding them. From 1973 there was 9. In the 2009 now there's 16 rules listed. We'll go through those pretty quickly. This is not a GD&T class, but it talks about a little bit of GD&T, but it also covers coordinate tolerancing. The 3 things that I really want you guys to take home with you when you're doing your drawings, in the back of your head, always think of accuracy, simplicity, clarity. Accuracy trumps all. If your drawing's not accurate, it's worthless. But you also want it to be simple and you want it to be clear so everyone can understand it. So keep those in the back of your mind. I see you taking a picture, but you can have our PowerPoint afterwards if you really want it. If you have a flash drive, anyone can have it. They're going to post them online too, or I'll email them to you. So we'll share. We don't care. But drawings are the law, especially when you start handing them out to people. And then dimensioning and tolerancing, the rest of this sentence is straight from the standard right before the fundamental rules. Shall conform to the following fundamental rules. So it's saying it's mandatory. Number 1, each dimension shall have a tolerance except for those dimensions specifically identified as reference, max, min, stock, and stuff like that. That's pretty important. Jeremy's going to show you a couple ways that you can satisfy this rule.
So I think we all know it, but if we focus on one small little hole here, you can see that currently we've got our basic dimensions locating it. A geometric control frame applies the tolerance. So, you know, that's GD&T, that's one way. Other ways available in SolidWorks are very simple. You know, standard locating dimensions, no tolerancing on them, therefore we go to the block tolerance.
What's your tolerance? And
then you can do direct tolerancing through all of the different methods here. Bilateral, limit, symmetric, min, max, fit with tolerance. So there's multiple ways to tolerance a part or a feature of a part. It's just according to the standard, it must be dimensioned and toleranced.
Yep. The only other way that he really didn't list it is just writing a note saying they're all untoleranced dimensions are basic. The second one over there, right?
All right, so dimensioning and tolerance shall be complete, so there's a full understanding of the characteristics of each feature. Basically, you know, just what we said, each feature on the part must be dimensioned, toleranced, must have size, location, and tolerancing. So it's pretty simple, but I always say, you know, every time I'm checking a drawing, is the feature located? Is it sized? Is it toleranced? If it's got those 3, you can move on to the next feature and go through the entire drawing that way.
I always think of height, width, and depth too, like your overall shape. There needs to be a height, width, and depth measurement. So I always check those 2. Just a little checklist in your head when you're reviewing your drawings. The next one is each necessary dimensions of an end product shall be shown. No more dimensions, those really necessary for complete definition. Excuse me. So why is it off to the right there? That's weird. So it doesn't really matter if you use coordinate or GD&T, but you shouldn't put extra dimensions on there. You only put as many dimensions as you need to fully define that part and complete it. So the first one's using coordinate. There's 1, 2, 3, 4, 5, 6, 7 dimensions on that one. The next one's dimensioned with GD&T, and there's 8. But there's no extra dimensions needed. It's fully defined.
All right, so dimensions shall be selected and arranged to suit the function and mating relationship of a part and shall not be subject to more than one interpretation. So assumptions are not allowed on a drawing, so everything must be clearly defined. If somebody has to make an assumption about where something's located or how 2 features are related, can't do it. So when you get back to functional dimensioning is something we like to talk about.
Yeah, functional.
You know, you notice we got the flatness call out on this, on the mating component where it mates to this part. You've got the perpendicularity to ensure that it can insert into the mate on the other component. You know, so keep in mind the function of the part when you're dimensioning, and to a point, also the quality and the manufacturing guys would very much appreciate it if you keep in mind their job also. So you can greatly reduce inspection requirements and manufacturing cost by taking that into account when you're doing your design and your dimensioning on your drawings.
Especially your datums, how you select your datums, your primary, your secondary, and tertiary. But these examples are straight out of the standard too. So I mean, we're not trying to make these up and prove our point. The standard really proves it for us through these examples. The next one, the drawing should define a part without specifying manufacturing methods. You can't tell them that you have to drill this or instead of reaming it or milling instead of sawing. You can't really specify that stuff. How you do set up your datums and your dimensions and your tolerances and all that stuff, you can kind of influence that stuff, obviously. But you know that's kind of a skill to get to that point. You also have to know about manufacturing and all the different methods and what your vendor has the capability to do and stuff like that. But you can't specifically specify how they're going to do that stuff.
All right, and that flows into the next one. Non-mandatory processes shall be identified with the appropriate notes, such as non-mandatory. So you put a tolerance on a hole, you think it's going to require that it's reamed instead of just using a standard twist drill, you can tell them to ream it. Non-mandatory, because they have to meet the tolerance on the hole. They don't have to meet the process to get there.
Yep.
So if a manufacturer wants to build something and scrap half his parts because he doesn't meet the tolerance, you know, that's up to him. He's just got to meet the tolerances at the end.
The next one's...
There are exceptions.
Especially when it comes to medium recast.
Okay.
Well, if it impacts the quality of your part in the end, then that actually becomes a mandatory requirement. So, little different situation, but yes. So you can specify how things are done if it is impacting the quality of the function at the part at the end. But as far as tolerance on a certain hole locate or hole size, something like that, typically you're not going to have to tell them or need to tell them what process they need to use to manufacture it.
Dimensions should be arranged to provide required information for optimum readability. True profile is big on this one, and you should always dimension to visible outlines. What I always like to see, and when we get new call-ups and stuff like that, when they're trying to pick their front view, which is very important, your front view should always be your most important view. It should be a true profile. And I always tell them if you have a part with a lot of holes, you should be able to see right through the holes. Seems like that's the simplest way to pick your front view. It's going to help you limit the amount of hidden lines that you're going to be dimensioning to or show in your front view. And most of the time it's going to be your true profile view too. So you can see in the standard that's exactly what they did, their front and their right side view. Optimum readability, they also grouped all the GD&T on the left side and then the basic dimensions on the right in between the views. Very important too, you should always try to dimension between the views. So if I had a top view too, I would most likely pull those bottom, the 12 and the 24, to the top, so it's in between the top and the front view. That's not a shall, but that is a very good fundamental rule to know and try to go by. But you know, grouping all the GD&T to the left makes it a lot more clear and readable. So that's why they've done that. This is a true profile view. You know, it's a weird curvature part, so that's their front view, or going to be their front view. So that really gets, when the person first sees that print, they're always going to go to the front view first and look at that. So it kind of gives them the overall, hey, this is a funky bent piece, and then you go from there.
So just a real quick SolidWorks thing here.
Oh yeah.
We open the part. Sometimes when things get modeled, you end up with a front view that you're not totally happy with. On this one, you know, we've got the front looking down, but say you wanted this as your front view. You know, you can hit normal too. Quick trick, if people don't know, if you hold down control and select two surfaces, then hit normal to, it's going to take the first surface, make it normal to that. The second one is going to be your top. So to get orientations that are a little tricky to get to sometimes, you know, if I just hit normal to that, rotating that way, I can click there, hit normal to, it's going to rotate it around. So second one's always going to be top. If I want that to be, so if I want to make this my front view, that my top, You can bring up spacebar, click on here to update standard view to front. Now my front view becomes that becomes my top. So you can always, after you've made the part, instead of going in and trying to change your base sketch planes and such, you can change your view orientation. You can always go back to standard, which was default. All right?
I think you're going to show them something on the drawing.
Oh, yeah. SolidWorks gives you multiple ways to put in your views and select your views. Hey, did I mess something up here? Looks like it.
Yeah, you set it back to default view.
Ah, so you'd changed that one before.
Probably.
So let's close that part without saving. Go back.
Desktop.
And I did that. So you got multiple ways to choose your views. When you first bring it in, you've got your view palette over here. I typically don't use that very much. I like to use over here where you get your standard view options and more options that you can change through. So when you change it, it's going to change all the dependent views. So good idea to try to get things set up beforehand. So first thing we do in a drawing, bring your views in, look at them, make sure you're happy with them before you start dimensioning, because you don't want to lose.
You don't want to dimension that whole part and then realize your front view was not your best view or correct, and then have to do that switch right there, and then it just throws all your dimensions off.
So we've lost all dimensions. So
make sure your front view is key. We try to teach everyone to use that side over there within our company, so that way if we share drawings or have someone work on the drawing after us, they know where to go instead of just clicking a button and then changing all those views on us or something. So we try to always set it up standard throughout the whole company.
all right, so next one, wires, cables, sheets, rods, and other materials manufactured to gauge or code numbers shall be specified by linear dimensions in your material. So when you specify that you want a .1196 thick steel sheet, that's 11 gauge, but in your notes you should specify it by the linear dimension. You can put the gauge number out beside it.
90-degree angle applies where center lines and lines depicting features are shown on a 2D orthographic view. So, you point to Jerry. There's a 90-degree angle. You don't have to put the angle in there. We all assume it in our head, but the standard actually says it's implied. That's a 90-degree angle there. And the center lines too.
All right, a 90-degree basic angle applies where center lines of features in a pattern or surface are shown at right angles. So if you've got something and you're locating it by GD&T, so this whole pattern of holes, it's a 90-degree basic angle. There is a difference in the way that the standard treats a standard 90-degree angle and a basic angle. We won't go over that here, but you can look it up in the standard. So there is a difference in that, that meaning.
So the front view, you want a limited amount of hidden lines. You want to make it the true profile view of your part. The most detailed view, it should also be the most detailed view. And then think about looking straight through the holes. That will help you set up your front view.
And sometimes those things are going to contradict themselves. So,
those aren't shalls, but
it can be a bit of a chore sometimes to settle on what the best front view is. That's why we like to go through and get all the views set up, section views, everything before we start dimensioning. Make sure that we think we can get the entire part defined.
The next one is zero basic dimension applies where axes, center lines, planes, or surfaces are shown coincident. So those two holes across each other there, they both have a center line, and on the right view, to show it with the center line, it's implied that those are coincident. You only show it once, but it's a coincident. The two axes are.
Next one's an easy one. Unless otherwise specified, all dimensions and tolerances are applicable at 20 degrees Celsius. So it's in the standard that should be at 20 degrees Celsius. Anybody comes from a manufacturing background that they have a quality control department, CMM, it's going to be set up in a temperature controlled room, or it should be. If it's not, it should be, because they should be taking those measurements at 20 degrees C. So I hope your quality guy likes it being a little cool.
Unless otherwise specified, all dimensions and tolerances apply in a free state condition, so the part isn't locked down and held in place. What was
humidity is not in the standard.
Yeah, I don't know of any reference to it.
So when you're talking materials that are
composites, that would be a big.
That would be something you would put in your notes if you need to control, make sure the humidity is controlled when they inspect the part. Put it in your notes of what it needs to be.
Yeah. You.
Okay. Unless otherwise specified, all tolerances apply for full depth, length, and width of a feature. So, not just the location of the first edge you come to, it's full depth of the hole. So, you know, if you're inspecting a part and you take a gauge pen and you go to put it, shove it down in there, and it starts, doesn't go all the way through, bad part. It's got to go completely through. So you can specify other than full length, width, and depth. You do that by chain lines. So you can do a chain line to say full width of the part, but only on this portion of it. So you can see they dimension that with basic dimensions. Same thing here. So we're looking at the run out only in this area. Doesn't matter for the first 7 millimeters. Doesn't matter after 17, but you need it in that area.
One of the big things with this is we did a big cart that used a lot of tubing, and we had holes on the end, and we had other tubings or bosses that fit into the end of these pipes, and they're really long. But we needed to control some of the features on it and stuff like that. We had to specify how far to measure in, or how far that GD&T control went on the inside of that pipe, because if not, it meant the whole 10-foot pipe, and you're getting into stuff that's just probably not even feasible then. So you really need to take that in mind. It's going to go the full length of stuff when you apply GD&T to it, unless you specify the distance.
So would you use multiple chain lines if you still have a tolerance, it's just not as tight?
When you don't specify here, that would become probably going to the block tolerances at that point in time. Or if you put a overall dimension on something and control one with a GD&T, it's going to go back to. So I guess your hierarchy there is going to be GD&T, then your standard coordinate tolerancing, then your block tolerancing. So yes, they're still toleranced, but it's going back to block probably at that point in time.
Dimension tolerances only apply at the level of the drawing that they're specified. So your part drawing tolerances do not apply at your assembly level. So keep that in mind. I mean, you just can't hand over an assembly drawing and not the part files and assume them and make them or hope to get the same part back from quality or something like that. So only apply at the level that they're actually shown on the drawing.
So this is where you're forcing your manufacturer to do part level checks.
Yeah.
And that's part of the standard, is he has to check the parts, make sure they're within spec, then you go to the assembly level, make sure the assembly is within spec. All right, last one, or this one is just right-hand rule.
Yeah.
So right-hand rule applies unless otherwise specified.
So the next point, or next part of this little presentation, is some of the changes. They made quite a bit of changes in the 2009. Some formatting, some new additions. Like I said, a lot of new examples. And they kind of just really reformatted the whole thing. So we're just going to go through, kind of give you guys some of those. But the first thing, standard 40 manual was changed. All the chapters were pretty much rearranged. They kind of went, they tried to put them in more of a sequence of most used. So that's the new kind of layout of the chapters or the sections. And that's just your typical chart of all the GD&T symbols. There we go.
So select datums based on the part's function to assist in manufacturing and inspection. So, basically when you're selecting your datums, functional dimension is going to come first. So what's the function of the part? Then keep it, like I said earlier, take into account how you're going to inspect the part, how it's going to be manufactured when you're putting those dimensions on there. You might save a lot of time and a lot of money by doing that.
And really what they did is they added a lot of verbiage to talk about this in the new 2009. I think almost a whole page they talked about it. So that's really what they're trying to emphasize more of this kind of stuff. The last is they added a lot of verbiage again on the foundation, the basic principles. So new material added for clarification or extend and enhance the principles that they're trying to get across.
All right, so definitions and terms. There's 5.5 because one of them's not really a new one, but they extend upon it further. And then there's 10 revised. I just put a few of them here. Your least material boundary, maximum material boundary, and regardless material boundary. Use the same symbol as MMC, LMC, and regardless doesn't have a symbol, just like standard. Pretty much same functionality as MMC, LMC, yeah, but it applies to profile tolerances now. So they did a whole explanation of what they are. One of the big things they did in the standard is expanded the use and the capabilities of profile tolerancing. Yeah. And to go along with it, you've got the new definitions here for LMB and MMB and RMB. They discuss unrelated and related actual mating envelopes and feature of size. We've always had a regular feature of size, holes, and now they've added in how to treat irregular features of size.
That's the half. So
when it comes to feature of size, one of the first things you need to realize for a feature of size is you need opposing elements. And in the past, it had always been, basically symmetric opposing elements. Now, with profile tolerances being expanded, you get those irregular shapes, and you can have non-symmetrical features of sizes. So when you look at a gauge pen or something like that, instead of being round or something like that, you can always go to a non-standard profile.
Oops, sorry. A lot of additional clarification given on hole depth. We always try to say here, we don't ever put the word through. Well, I won't say that, we don't ever, but we try not to. If the hole on the drawing shows that it goes all the way through, either with a front view or a hidden line view, but if it's clearly shown that the hole goes all the way through, you don't have to put through on your drawing. Some people think you have to have that. You don't, and you see a lot of examples where they don't have it in there. But you just got to make sure that it's shown that the hole goes all the way through somewhere on the drawing sheets.
So like here, we've got one hole. You can see the hidden lines for it here, another one here. There's a single center line running through them. It's clearly shown where that hole goes through. So at that point in time, you don't need to turn around on the call out and say through all or through. It's a redundant, it's just a redundant requirement at that point in time.
And SolidWorks puts it in there automatically. You can change that. You can go into notes.
You go into the whole call out settings, and you can customize those.
You can change that.
So can save a lot of time if you actually pull up, it's just a text file, pull it up, find the type of hole that you're calling out, modify it to what you want it to be, and then every time you call it out after that, it's going to be correct.
Yeah. Do you have a paragraph reference for that? Because that's kind of something that's always going round and round.
A paragraph reference in the standard?
When your boss and other people, he says always put it on there.
In here?
Do you have a paragraph reference?
It talks about the using through, but
1810. Is that what that says in the bottom right?
The way it uses through in there is it may be used. It doesn't state that you need to use it. I know it is a may. It's not a requirement to use it. It's also not a requirement not to use it in the 94 standard.
I can look it up. That's from the 2009. This is the 1994. That number. But that picture right there, and there's a whole bunch of verbiage that goes along with that image.
He's talking about the through.
I know that came from the same area.
Okay.
When they talk about the through.
We can discuss afterwards.
Yeah.
Oh, this is me, isn't it?
Sure.
Sorry. General tolerancing and related principles. So GD&T, preferred method is to control form, orientation, and location in that order. And direct tolerancing is used to control size of features. So they went through the standard in 2009 and did make it clear that the preferred method of tolerancing parts is GD&T for location, form, and orientation on size of features, standard coordinate. So that's not actually in the standard.
Tolerance accumulation, basic dimensions used, style. When you're used, so what this is saying is when you're using basic dimension in GD&T, it doesn't matter if you use chain dimensioning or baseline dimensioning with your basic dimensions. They're theoretically exact, so it doesn't make a difference when you're using GD&T. When you're not using GD&T, it makes a big difference because then you're going to get your tolerance to stacks, and we'll talk about that here in a second, but there is a big difference there. So yeah, it doesn't matter which way you use it.
One I'm looking for, but
I don't know.
I think
We have a picture of it here in a second.
all right, we'll show it later. So this is showing all the symbols that are used in the 2009 standard. There's 6 new symbols all over: continuous feature, independency, unequally disposed profile, movable datum target, and datum translation. We'll talk about a few of those later.
Go ahead.
So remember we talked about a regular feature of size. So we've always been able, well, in 94 and now in 2009, you were able to do control of slots using a positional call out, so true position. In 94, they required the term boundary to be underneath the GD&T call out. 2009, you no longer have to do that. You can, you don't have to. And just real quick thing so people know is now in SolidWorks, you have a note block here where you can put things in. So you can, say separate requirement or whatever the statement is, put it in, it shows up directly below it. When I hit OK, the other option to do it, this was brought in, I think, in 2012.
Yeah.
You've always actually been able to put it over here in the text in the properties. So, and that's linked to the GD&T at that point in time, so it's not a separate note floating around in your drawing space.
Yeah.
And I guess the reason why that's important is, you can group notes in SolidWorks, but when you actually link a GD&T symbol to a dimension, that functions as the group, so you no longer have the ability to group another note to it. So you need to actually put it in that GD&T symbol.
The next,
Are we done with this one?
yeah.
Okay.
The next one is planarity, and that's really the biggest thing that changed here. Is it functions the same as the 1994, but the symbol changes from surfaces to just an X now. And you can see from the top there, you used to have to write 2 surfaces. Now you can just do 2 times on the profile of the surface GD&T call out. So just a little bit less writing, a little bit cleaner. Kind of makes more sense that way. But that's pretty much a big change on that
and
one.
2X is pretty much the standard for multiple throughout on drawings nowadays. So instead of 2 places, pretty much everything's became 2X.
Can you call it typical?
You can use typical. I try to stay away from it as much as I can because typical really allows for a little bit of assumption in a drawing because, you're not telling them how many times something is applied at that point in time. So I have done it, and I've used it where there's really not a good option other than that, but I shy away from it if there's actually the ability to tell them the number of instances. All right, so this is about limits of size and continuous features. So that was one of the new symbols, was this CF symbol, continuous feature. And what that allows you to do is to identify a group of 2 or more features of size and treat them as geometrically as a single feature of size. So when using the continuous feature, your extension lines between the features may be shown or omitted, so you don't have to show the center line extending all the way when you use that continuous feature symbol. But on the other flip side of that, a single extension line running through both of the features or all of the features doesn't mean that it's a continuous feature. So what you have is, we have a few examples here. So when you put continuous feature, that means it applies for both of these diameters, right? So here's the GD&T as it applies to that. Same thing can be done.
Internal.
So we've got two slots, one running through one way, one running through the other. So what you end up with, and through a tube actually, or so what you end up with are a slot here and a slot here when you look through that. So you apply the continuous feature, must be treated as one. So anytime you drill a hole through both sides of a tube or something like that, the way the standard treats that without continuous feature is that's two separate features of size, so two separate holes. So you have to count that in on your quantities and everything like that as separate items. Here you apply continuous feature, treats it as one. And one last example, doesn't have to be regular, so here we've got maybe a slot cut out for a O-ring or something like that, and then we have another notch in it. The continuous feature, every one of the surfaces, so applies full length and width.
The next one is unilateral or unequally disposed profile tolerances. It's indicated with an unequally disposed profile tolerance placed in the feature control frame, and it's telling you how much material is added, additional material to be added to the true profile. Can you point to this stuff?
Oh, sorry.
No, it'd be.
So
yeah.
Basically what it boils down to is you've always had the capability to do a unequally disposed profile tolerance. Under 1994 standard, you had to put chain lines in there and dimension them using basic dimensions showing how the profile tolerance is distributed around your theoretical surface. Now you can use the circle U symbol for unequally disposed, and then you put a number after it which tells you how much material can be added, so how much tolerance you get in that direction. So all of it on the outside, all of it on the inside, so you get a 0 in there. And then 0.2 means 0.2 material growth, so 0.6, so 0.8 minus 0.2 on the inside. So not a new capability of the standard, but a new way of showing it that saves a significant amount of time.
Oops, sorry.
This is another new symbol, and actually a new capability of the standard is using the all-over specification. So we've got a single profile tolerance called out, and we've got our all-over symbol. You can also put all-over underneath the feature control frame instead of using the symbol. That is okay according to the standard. And what it does is creates a full three-dimensional tolerance zone around the entire part. So at that point in time, you're controlling the entire, every surface of the entire part or exterior of the part with one profile call out.
The next is non-uniform zone. Non-uniform tolerance zone is maximum material boundary and at least material boundary of unique shape that encompasses the true profile. You have to list it out. You have to write non-uniform, replacing the tolerance with non-uniform, and then you have to actually provide basic dimensions to actually show your non-uniform zone there. Drawing for the non-uniform tolerance zone in the leader line from the feature control frame is directed to the true profile. But I think that's mostly on that. What you just have to pretty much basic dimension it out.
You can define it as anything you want, but you must dimension that tolerance zone with a basic dimension and reference it as non-uniform at that point in time.
To go along with that, you can use that too to smooth out transitions between profile tolerances too. And you can kind of see where A or B and C there are. It just smooths it out, and the bottom shows what that means.
All right, so this goes back to the expansion of profile tolerancing within 2009, and one of the things they added is you can do a composite profile tolerancing for a pattern of irregular shapes at that point in time. Functions pretty much the same as your composite profile tolerancing or composite tolerancing on true position callouts. So you can see how we've got, you know, back to our basic datums, and then we're going to control it tighter back to the A datum. Again, it's a composite tolerance because there's one symbol for both blocks instead of individual symbols. And this is the definition of what that means. So we've controlled the pattern with a composite tolerance just like we would if we were doing a true position call out. Yeah, I can take this one.
Yeah, go ahead.
This is one of my favorite things that they added in the standard, and I think the capability was there, but they never explained how to use it in the past. But in our work, we use a lot of nut plates when we're installing things. So you get a single hole with 2 holes around it, and you get that all over the place. So what you want to do is you want to control the 2 rivet holes back to the main hole. So wherever that main hole is located, we can tolerance it with a certain tolerance back to your A, B, and C datum, and then control the 2 rivet holes back to the center hole. And what they've done is allow you to control repetitive patterns and features of sizes with a single call out. And to do that, you know, you do a detail. They're not showing it here, but you need to locate the main portions of the pattern, right? And they're going to be controlled back to A, B, and C. We're making that the D datum, and we tell it the number of places and that it's going to be an individually. And what that means is for each one of these cutouts with the hole pattern, so each place you're going to put a connector or whatever, that the 4 holes around it are going to have a D datum of the individual hole. All right, so then on our profile or our true position call out for each one of the 4 holes in our detail view, we're locating it with a large tolerance back to A, B, and C, and a much tighter tolerance back to A and D. And this is a multiple single segment control. All right. One note about it is when you're doing a detail view and it states this in the standard and you say 6 times detail A, you don't have to say 6 times at each of these locations. So they've done it both places. A little redundant in my opinion. You can say just datum D individually and then individually on this. When you've got a multiple single segment, the individual needs to be located next to or adjacent to the feature control frame that it applies to. Do we want to show?
Yeah, go ahead. Show them your.
All right, so
Just a little.
this is one of the favorite things that I've found in SolidWorks, and
This goes along with what he's saying. They have a lot of nut plates with a lot of rivets, and putting all those in is not fun and time consuming, and it also bogs down the machine when they're rebuilding and stuff. So this is just a little shortcut, and some of you might already know this, how to do this.
so when you're talking about putting 30 or 40 nut plates into an assembly, it gets time consuming, very computer intensive, as Rustin said. So what I do is I put in my main hole pattern, whether I put in a single hole and pattern it or I dimension them all in one sketch as I've done here. I put in the main hole pattern, and then I don't want to show that yet. I'm going to come in, and on one single hole of that pattern, I'm going to create a countersunk hole for my rivet. I want all drill sizes. And if I remembered what it is off the top of my head, I would have put it in. Through all, I'm going to make a countersunk, and numlock is not on. 100 degree. Position. I'm going to put the 2 of them in. I always like to put a center line connecting them, select the midpoint, make it concentric to my hole, so wherever I move the main hole, it moves with me. Rustin, you did not put my D key in.
Sorry.
So
Should have got here early.
I've put one in. Now, how do I get them rest of them in easily? Easiest way to do it that I have found, and everything works well, is do a sketch-driven pattern. So I'm going to tell it to pattern that feature using this sketch, and it's going to pop it in mislocated. Select center point, select the middle, so now I have all of my holes in for my nut plates. All right, works very well. The only downside I've found to this, and actually becomes an upside most of the time because the way we do it is when you call out the quantity of holes in your drawing, by default it's going to say 2 times on the countersunk holes. But we mostly dimension ours nut plate holes in a detail view, therefore I only want it to say 2.
Yeah.
So just keep that in mind. Do you have the assembly open?
No, I didn't make one yet.
All right, so we're going to make an assembly from the part.
On a whole table, would it say 402 or would it have a
2. I'm pretty, yeah. It's only going to say 2.
And let's see.
Well,
Whole
Yeah, I
table,
don't know.
I haven't tried it because we don't use whole tables often,
not on
so I don't
singles.
know the answer to that.
on the assembly, what he's about ready to do, I think it will pick up the right number. But yeah, I don't know.
Oh, didn't put in the mouse gestures either. Man, I thought you were going to do all that. So I'm just going to mate this in real quick. How many people use the G key to zoom?
Good one.
It's actually that one's in an odd place. It's actually very helpful on large assemblies. We put that in, come back in, put in our rivets. I'm going to want to put it in multiple times. Use tab, change that orientation. So I've put nut plate rivets in one time. Now we can come in and use a feature-driven component pattern. Select my features or my components, driving feature. You can change the seed position so you don't always have to select the one that was the bait or the first hole you put in and complete it. Now I have a derived pattern of components that controls all of my other nut plates and rivets.
Saves a lot of time. We actually did a test too, a real short little test on the rebuild times and stuff. And it was like, was it over half time savings?
It was significant.
Yeah, it was significant. Where we have everyone doing this now in our company when they're doing a lot of nut plates and fasteners and stuff like that. You don't have to do it just for a nut plate. And it was significantly time saving in your model. And it's really simple to do.
So basically, it doesn't have to solve all those mates at that point in time. It treats them like a pattern. So it's a very significant number of mates that it takes out of your assembly.
Yeah.
All right.
So the last bit, and then we're just going to run through these. These are some of the things that we come across a lot that kind of bug us or very commonly broken. And then it's open to you guys if you have anything too. And a lot of times people shout stuff out and we don't know the answer, but someone else will.
And I'll make this statement, not necessarily rules, but more of drawing conventions that we don't prefer. How about that?
Dimensioning between the views. It's big, it's simple, but it makes stuff so much cleaner. It goes back to the clarity and simplicity. And like I said, they grouped all the GD&T on the left side for the holes, and then they dimensioned between the front and the right side. They could put it to 12 or 24 towards the top too if they wanted to. But you should always try to dimension between views.
All right, before we go any further on that, we forgot to show something earlier. SolidWorks gives you some tools to help you arrange dimensions.
Oh, yeah.
So say we've put all our dimensions in and they're just all messed up, right? So what I can do is I can select those dimensions, and when you get a little pop-up here, we have different ways to arrange the dimensions. So I can just click Auto Arrange. It goes back to the settings of the document and arranges those dimensions based upon that. So you can see it put them in pretty good shape. There's a few things I don't care for, so I'm going to drag that to the other side. And if I want to select the two of those and tell it to align them collinear, it does it for me. Another thing that, and we've already done it on this one, so let's delete that out real quick. So I've got that dimension in there, and say I want to drag it and align those. Well, now the extension line of my dimension arrow is over in my other dimension. What I can do is, while I've got it selected, is right click over the top of that arrow and say hide dimension line, and I hid the wrong one. Undo. Not doing a very good job of showing this one. All right, right click over the top of it, hide dimension line. So hid the dimension line, I can align those. So it's no longer having that interference.
It's much cleaner looking.
So SolidWorks does a lot of things to help you make the look of your drawings clean. You just need to take advantage of it.
The next one is stagger dimensions for clarity. This is right out of the standard. The picture is you should stagger them when you have a whole bunch of them, just like it's shown there, so people kind of read it better. Centerline breaks. This is the big one. Whenever you have holes, there should always be a little plus sign. You should always see a little plus sign and then a break into the next one. So that's pretty big. And then on the corners of the part where it says the visible gap, you should always have that. The spacing. There is a set amount, 6 millimeters and 10 millimeters.
Those are minimum values.
Yep, minimum values. So that's pretty important too. But a lot of times we don't see that little plus sign, and that's kind of a little pet peeve of ours. So. Yeah. And most of that time is because when you're dimensioning and you have center marks in there, you got to click on the center mark, not the hole, to get that to work right. And
SolidWorks has done a good job of improving that over the years. Used to, you pretty much had to put your center marks in, dimension to them to get the break. Nowadays, if you dimension to your hole, add center marks, it does a pretty good job of being smart enough to realize what you're doing and give you that break. I want you to avoid crossing dimension lines.
Oops, sorry.
Oh, or did I go too far?
No, that's me.
Yeah, so basically, when you can avoid it, you don't want the 20, the small dimension, over the top of the big dimension. So you don't want to cross dimension lines unless you have to. There are many, many times where you have to. Just try to keep it to a minimum. And one thing we do to prevent that a lot of times is, we'll dimension a pattern of features on one side of the part, and sometimes maybe the overall dimensions on the other side of the part to keep from crossing those dimension lines. This one is part of the standard. Anytime you're doing a chamfer that is not a 45-degree chamfer, you can't call it out like this, or you can't say 2 by 2, because at that point in time you're making an assumption on which side of the dimension you're calling out. So you must give a dimension and an angle.
A lot of people don't know that one, or they just don't think about it, but it makes sense. Tolerance accumulation, like I was saying earlier, if you're using GD&T, and you're using basic dimensions, it doesn't matter if you use chain or baseline or direct. They're all the same because the tolerance is in the feature control frame. But if you're not, if you're using coordinate, and you want the least amount of tolerance stack between two important faces or features or holes or whatever it is, you need to use the bottom one, direct dimensioning. If you use chain dimensioning, you're going to get the greatest accumulation between X and Y, and baseline is going to provide the second most. So keep that in mind.
All right, and to go along with that, and it might take me a second to find it in the standard, but it just sort of popped in my head, is when you're dimensioning a pattern of holes and you're not using GD&T, and a lot of times you want to come in and say you've got 10 holes in a row, a single line. So repetitive features. One of the ways they tell you to do it is shown right here in this view here, of 17 times 16 equals a total of 272. Well, you're telling them the 272 is a reference dimension. So at that point in time, your 17 times 16 is a bunch of chain dimensioning. So you get tolerance stack up going across through there. So that's one of the places where GD&T does a very good job of eliminating that tolerance stack. So by the time you got to the end of that pattern, you might have an inch of tolerance stack up. Yeah. So that doesn't eliminate that tolerance stack up when you call it out that way, because your overall is reference at that point in time.
It's left. Tolerance.
Oh. Center of a feature / part symbol, center line symbol. It's not in the standard. It's an obsolete thing. There's a reason why a center line has a specific format. It's a center line. So
you still see it once in a while.
I've seen it on so many drawings. I've put it on drawings in the past myself before I started reading through the standard and found out it's not a symbol in the standard.
It's not in the 94, and it's definitely not in the 2009 anywhere.
So your center line has a specific font for a reason, or format for a reason.
We talked about the whole callouts, the through. You don't have to. We can try to look up the specific part for this gentleman over here, but you don't have to have the through as long as you show that it goes all the way through and there's no confusion there. Sheet templates is another big one. There's a standard that covers the sheet templates of about every size that you'd use, but we constantly get sheet templates that are just all wacky and weird sizes. The borders are wrong. The line thicknesses are wrong, and the title block in the bottom right, they're all different sizes and stuff. I mean, if you just open up that standard, the 14.1, it tells you exactly the measurements of every one of those blocks, and there's optional ones. It gives you all those optional ones and stuff like that too. So, I mean, it just kind of makes sense to use it that way, unless you really needed some customized template, then I guess, but I don't know, it just makes sense to use that.
Yeah, so if you're referencing 14.100 on your standards, technically your sheet template should be in accordance with Y14.1.
Yeah.
And then the last one we have up here is your projection symbol. So your first and third angle projection. How many people deal with companies overseas? A lot of you. You have a first or third angle projection on your drawing template, don't you? You better, because U.S. is one of the few countries that use third angle projection. Most overseas companies use first angle. So basically, third angle, you're looking at the outside of the box as you rotate it. First angle, you're standing inside of it and moving around. So I agree totally, but hey, if you deal with companies outside of the U.S., you better have that symbol on your drawing, or you're going to get some parts wrong eventually, and it might be a lot of them.
Our customer doesn't believe in putting it on the template, so that's why it's there.
Yeah, it's one of our pet peeves. They say no every time.
It's so simple to do.
Every time we update a template, we put it on there and send it to them for approval, and they want us to remove it, and we're just like, come on. So that's our pet peeves. If anybody wants to share some pet peeves with us, and we can discuss them as a group, or any questions, we'd be glad to take those now.
Yeah. A couple of questions.
All right.
The first one has to do with SolidWorks. Any idea when SolidWorks is going to give us the rest of the symbols? Loaded. I know that we can make them.
The 6 new ones you're talking about?
Yes.
I would have no idea.
I have no idea when SolidWorks is going to incorporate symbols.
Including what?
Paper.
Yeah, we don't use a lot of the random. I mean, we use the positional. It's very rare that we'd ever use any of these random modifying ones. So I actually don't even know which ones that they don't have. Like, I don't know which ones they don't have and do. I mean, I know they have a lot of them.
The unequal for one.
The unequal.
Yeah, there's several of them.
I used to have the contact for SolidWorks drawing development or something like that. She was at my presentation 2 years ago. I don't know if she's still in charge of it or not. There's no SolidWorks people here, is there? Because last time she was just snuck in. And so, yeah, I don't know. We don't work for SolidWorks. So.
2013, we have unequally disposed profile.
We haven't upgraded to 2013, so we're still on 12 at our company.
I don't see continuous feature, but that wouldn't be inside of that. So very well might be added.
Yeah.
They normally do a pretty good job of getting stuff in quickly when it's symbols and such. But,
especially if ISO has it too, or one very similar, they always try to keep up with that too.
Okay, so, second question. In reference to section 1, paragraph 4, what are your thoughts on...
This one or 2009?
Either one.
Well, they rearranged quite a bit from...
Section 1, paragraph 4 is the same thing.
Oh, okay.
With regards to tolerances, all dimensions have tolerance.
Section 1, paragraph 4?
Or 1.4?
Or,
Okay. Fundamental
Okay.
rules. Dimension tolerance shall clearly define engineering intent and conform to the following. A, each dimension shall have a tolerance. What about it?
Then there should be something in parentheses.
oh, there we go.
Commercial stock size,
No, go down.
indirectly in the case of basic dimensions.
There you go. Indirect basic dimensions.
So your basic dimension is a,
With regard to datum targets, where's the tolerance? Where's the tolerance come from on a datum target?
well, it's not a toleranced item. A datum target is a theoretical.
It's inspection.
It uses a basic dimension and all dimensions have tolerance.
Well, it's a theoretical dimension, though, at that point in time.
Dimensions have tolerance.
I see where you...
You're getting in semantics of the way they've written
Yeah.
There are people that are dogging me about that.
Really?
And I want to, I'm trying to get a synopsis or
Yeah, because it says
bit of information.
all of them have a tolerance, but yeah, that one doesn't have a feature control or feature control anywhere giving that tolerance. Because there's no positional.
Well,
Does that say
it's
anything about
just like
positional?
a datum simulator. You know, a datum is not a physical object or a physical surface. It's a theoretical surface, and that's what you're getting into with your datum target.
You might have to add a block to say
it's
it then.
theoretical at that point in time, and you're probably dealing with gauging companies.
The gauging that's setting up for either manufacturer or gauging that is building the fixtures or quality control that's checking our either weld nuts or checking our forgings.
So, you know, I came from the automotive industry and dealt with that slightly. Internally, our company, we had a certain amount of tolerance that was allowed to be built into our gauging. So what we did is, to a point, took some tolerance away from the part function and put it on the gauge. That way, we knew where our gauge was at. It was, you know, 1/10,000th off or something like that. We make the whole location or the pin off enough that we knew we were within tolerance of the part if we stuck the part up there and measured it.
And in reality, I understand that forgings, castings, weld nuts that are in subsequent machines, yeah, you're going to have a lot of slop there.
Yeah.
But there are those who say, okay, you're putting a basic dimension up here. 1.4 says all dimensions have tolerance.
You could always add like a note in the bottom or something that says all untoleranced basic dimensions have this.
Can I add
This.
or something?
Yeah,
One of the very first paragraphs says this is not a gauging standard, it's a drop.
that is true.
He is correct.
That is.
When you put a basic dimension for a target dimension, you actually put in one of the ASME B series.
The gauging one?
Fixture design, and that design will tell you you have to be 10 times better than whatever your tire tolerance of the under.
Yeah.
So it's a different standard that controls that tolerance.
ASME Y14.43 referenced in 1.1.6.
And it does
So
say
he is
reference to
correct.
gauging, yeah. Not
So-
intended to gauging standard, any reference to gauging, yeah.
So at that point
It
in
might
time,
be your argument. I know what you're saying. I can see where the,
Did you say it's 4.3?
what'd you say?
Did you say that
14.43, yes.
Yeah.
I work at a plastic factory. Air targets refer to the gauging standards.
So he's saying datum targets refer to the gauging
Yeah.
standards. But again, you will read this through here. When it talks about datum, a datum is a theoretical plane, or it's theoretical.
Yeah.
It is not a physical surface that
Yeah.
you can touch.
Yeah, they're not
at that
arguing
point in time.
about that, yeah.
So you have datum simulator, which is what your gauge is going to have datum simulators.
I would use that as your argument. Is it's not a gauging standard, then you need to go to that. And I don't have a lot of experience with the gauging standard.
So from a gauging
If any.
standpoint, a setup fixture would fall into that category too, if you follow that same train of thought.
I would think so.
I would
yes.
think so. get away with that argument, I would think. Yeah.
And it actually states it right here.
That's at least some sort of an argument point for you.
14.43 is dimensioning and tolerancing principles for gauges and fixtures.
Oh, and fixtures. There you go.
Okay, and